Today we have to discuss about the balancing of chemical equations. Important thing that it always obeys the law of conservation of mass, which is a matter can neither be created nor destroyed. It must be balanced so the number and type of atoms reacting is the same as those being produced. In the sense, both the reactants as well as products should be having the same type and number of atoms. Look at this, this should be balanced. How? We have to add a coefficient to adjust the numbers of formula so there are equal numbers. Look at here, hydrogen, oxygen and H2O. It has only one coefficient. When we have to add 2, it will be balanced. So adding coefficient only there. So next rule is there, never change a correct formula to balance an equation. There is no right, we should keep the same. And can you assume how many atoms are there in sodium, chlorine and sodium chloride? Look at that, sodium has only 1, chlorine has 2 in the LH side and 1 only each for right hand side. Now is it sodium has 1 each for LHS and right hand side, but chlorine has 2 in its LHS side and right hand side 1 only, so it is unbalanced. Now let's see that how we can balance this. So see, add a coefficient 2 in the right hand side and the sense sodium chloride, so the total number sodium will be 2 and chlorine will be 2 in the RHS side, but it is still unbalanced there. So look at that sodium, when we are adding 2 in sodium, so it will be equalizing for LHS and RHS as well as chlorine, so this reaction equation is being balanced. Now next one, look at this equation, C5H12 plus oxygen gives CO2 plus H2O. Note here, carbon has only 1 applied as well as hydrogen also applied once in LHS and RHS, but oxygen has twice in RHS side but only once in LHS. So consider this to balance last only, oxygen has to be considered to balance last only. Now look at the number of atoms for LHS and RHS. Carbon has 5 in LHS but only 1 RHS. Hydrogen has 12 in LHS, 2 only in RHS. Oxygen has 2 and 3 respectively. So we have to balance this. Look at that, carbon 5 in LHS and only 1 in RHS. So when we are adding coefficient in the RHS side, so it will be balanced for the element carbon. Next one, when we are adding 6 in the for the hydrogen in the RHS side, it will be 2 into 6, 12, as will be same with the LHS. So next one, oxygen. Finally, oxygen should be added in the LHS side to maintain with RHS by 8. So 8 into 2, overall 16, and the RHS addition also will be the same, 16. So that's a balanced now. Look at the equation again. Note here, consider to balance last only if any elements which appear more than once on either side. In this case, oxygen has twice appearance in RHS. Next one, another rule, treat polyatomic groups. Polyatomic group in the sense more than 1 atoms. So look at that, nitrate NO3 and next one phosphate PO4. So these are example for the polyatomic groups. We have to treat them particularly as a single only. So look at that, calcium. Calcium has 1 in LHS and 3 in RHS. Nitrate considering as single, 2 in LHS, 1 in RHS. Potassium 3 in LHS, RHS 1. Phosphate 1 in LHS as well as 2 in RHS. So we must balance these with the addition of coefficient over the calcium 1 in LHS, so must be added 3 as the coefficient over there. Look at that now, 3. When we are adding 3 along with the calcium, it is balanced for both sides. And next one, look at that nitrate only has 6 by addition of 3 over there in the LHS, so we must add 6 over there in the RHS to balance this. Next one, potassium already 3 only there in LHS, but when we added 6 in the RHS side, so it's become 6. So to get it, we have to add 2 in the LHS side, so now it's balanced. Next one, phosphate is already 2 in the RHS side, but after adding 2, it's also become balanced. So once again, the rule is there: polyatomic groups appear is on both sides, it should be considered as the single unit to balance. And these only right now, we can see next time.